so bad. And it's not that bad. It's just a lot of reading, and kids don't like to read. So that's the challenge we have to overcome. Stick with it. Read it 3 times. Read it 4 times. Read it 7 times. I read it 2 or 3 times. So I would think that you would need to read things 5 or 6 times, which you got to have some willingness to stick with that. All right, so sample proportions. So we talked already about we're very, very rarely going to be able to survey an entire population, okay? We're going to have to focus a lot on samples. And then we'll look at our samples and we'll use the statistics from our sample to generalize to the entire population. So in this first exercise, a school is trying to determine the proportion of students who own cell phones. They do a survey of all juniors, circle that, all juniors, and find that 168 out of 236 have cell phones. They then take a sample of freshmen, so it's only a sample of freshmen, and find that 30 out of the 52 that they sampled own cell phones, okay? One of these is the population proportion, which is just the P, and one of them is the sample proportion. And because we surveyed all juniors, we can come up with the proportion of the population of all juniors. So the P there, calculate the population proportion, so just a lowercase p gives you the population proportion, was 168 out of 236. And we're going to do that division and round it to the nearest hundredth. And what is that, Molly, rounded to the nearest hundredth?
0.71.
0.71, good. And that statistic is concrete. That's all juniors. We know that. But when we look at our freshmen, we only grabbed a sample of how many? How many freshmen did we sample? 52. We sampled 52. Out of those 52, how many had a cell phone? 30. This is not the population proportion. This is the sample proportion, so the symbol's a little different. It has a hat above it. Now, this is just an estimate of what happens for the entire freshman class. 30 out of 52 is probably not going to be exact. It gives us to the nearest hundredth 0.58. But more likely than not, if someone was a little more persistent than I was, and they decided that they were going to survey all of the freshmen, and they were actually going to find the population proportion, versus I was lazy and I only found a sample proportion, the population proportion is probably not exactly 0.58. It's probably in the ballpark, but it's probably not exactly 0.58. We know that this one is exactly 0.71. But this population proportion is probably not exactly what our sample turned out to be. That would be pretty coincidental, although it's probably in the ballpark. Here's what's tricky about stats. We have to decide, is that difference, keeping in mind that this was the whole population and this was just the sample, is that difference enough to conclude? And with how much certainty could we conclude that freshmen actually own fewer cell phones? And that's kind of the question we're going to ask ourselves. Because it could just so happen that when you chose your 52 kids, you got unlucky and you happened to be talking to a group that all hangs out together, and that whole group just happens to not have a cell phone. Okay? Or the flip could have happened. We could have gotten lucky and actually had in our sample, more people had a cell phone because we happened to be talking to a group that all have cell phones. So there's a little bit of, when you're picking a sample, there's a little bit of luck involved. Who did you pick? You know, if you get your sample randomly, and remember we talked about how important that word randomly is, if you get it completely randomly, the chances of something coincidental happening, like you coincidentally talking to all the kids without a cell phone, are much, much less, which is why we so often have to take a sample randomly. Like you wouldn't want to go up to a certain lunch at the lunch table in the lunchroom, and you wouldn't want to say to those kids, all right, I'm just going to use you as my sample. Because more times than not, kids hang out with other kids that might also have a cell phone. And kids who don't have a cell phone might more often, for some reason, and that's just a might. It's not necessarily true, but if you don't have a cell phone, you might be more apt to hang out with other people who don't have a cell phone. Okay? It's just, but by taking random samples, you take that coincident stuff out of it. Does that make sense? Okay? So those are kind of the questions we're going to be asking ourselves and the statistics that we're going to run to kind of see whether or not this is significantly lower enough to conclude that freshmen own fewer cell phones or not. Okay, exercise 2. We would like to determine how likely it is that a sample of 52 out of a population with a proportion of cell phone ownership of 71% would result in a sample proportion of 0.58. Okay, so we're going to assume that the freshman has the exact same ownership rate as the juniors. So if their population proportion was 71%, how unlucky would we really have to be for our sample to only produce a 58% ownership rate? That's really what we're doing. Let me restate that. We're going to assume that the freshman ownership rate is 71%, so it's exactly the same as what the juniors was, and we're going to calculate how unlucky we would truthfully have to be in order for this to be so much lower. Or is that just luck of the draw, and it wasn't that unlucky, and it would happen often? We're going to see that. So you're going to find on my webpage some programs. And the first program is it's a simulation. So there's computer software that will take a sample of 52 kids out of a population of whatever we set the population to be. I'm going to have to read that a little bit more carefully. We'll do that over and over and over again, 100 times, 200 times. We only took a sample once, right? There's computer software that are going to take a sample of 52 kids hundreds of times, and we'll see how likely it was that 58 came up. Does that make sense? Okay? So I'm going to, this is where the video is going to be tough, because I don't think it's going to show this.